Before I explain what cloud is, I want to tell you why it exists. Because most people who teach cloud start with AWS services. They start with S3 buckets and EC2 instances and VPCs. And you memorize those things and you pass a certification and you still do not truly understand what you are working with. I am going to start somewhere different. I am going to start with a human being. Before any technology existed, before computers, before phones, before radio, there were just people. And people could communicate. You and I standing here right now, I can hear you, you can hear me. The communication is perfect. Now start walking away from me. 10 meters. I can still hear you, but you are getting quieter. 50 meters. You are raising your voice. 100 meters. I can barely hear you. A kilometer away. You are gone. Distance kills communication. That is the original problem of the human race. Not hunger, not war, not disease. The fundamental problem underneath all of those is that we cannot coordinate when we cannot communicate, and we cannot communicate when we are far apart. Everything that was ever invented in the history of technology, every single invention, exists to solve that one problem. How do we make communication travel across distance? That question is where cloud begins. Not in a data center, not in a server room. In the moment a human being realized that being far away from another human being meant being cut off from them. Now, let me show you how that story becomes infrastructure. Engineers started to understand something about sound and communication. Sound travels on waves, electromagnetic waves, invisible roads that carry information through the air. And those roads, those frequencies, have a physical reality that most cloud engineers today have never been taught. I know this personally. I worked at Centec, South Africa's national broadcaster. I maintained FM radio transmission towers, TV broadcast equipment, satellite receive chains, C band dishes, KU band dishes, microwave radio links across mountainous terrain. When a radio presenter speaks into a microphone in a studio in Johannesburg, their voice does not magically appear on your radio in Cape Town. Their voice is converted into an electrical signal. That signal is modulated onto a radio frequency. That frequency travels through the air at the speed of light. Your radio antenna receives it, converts it back to sound, and you hear the presenter as if they are in the room with you. That is not magic. That is physics. That is engineering. And here is what most people teaching cloud never tell you. The internet works the same way. Your WhatsApp message, your bank transfer, your streaming video, your API call from a Kubernetes pod to an AWS Secrets Manager endpoint, all of it still travels on something physical. Cables, fiber optic cables running under the ocean between continents, frequencies carrying your 4G and 5G signal from your phone to a tower, that tower connected by fiber to a building, that building connected to another building, eventually reaching a data center somewhere where your data lives. Even your 5G signal, the most advanced wireless technology available today, hits a physical tower. That tower has a fiber cable running from it into the ground. That fiber connects to a backbone network. That backbone connects to a data center. IP addresses do not float in the air for free. They ride on something physical. In South Africa, Independent Communications Authority of South Africa controls the radio frequency spectrum. They decide which company can use which frequency for which purpose. A frequency is a road, and just like a physical road has a speed limit and a capacity, a frequency has bandwidth. Bandwidth is how much information can travel. When you hear people say the network is slow, they are not speaking metaphorically. There is a physical road somewhere that is congested, too much data trying to travel through a cable or a frequency that was not designed for that volume. This is the foundation. This is what everything else is built on. Before you can understand cloud, you must understand that underneath every cloud service, underneath every database, underneath every API call, there is a physical cable and a frequency and a signal traveling at the speed of light from one physical location to another. Cloud does not change physics. Cloud builds on physics. Now, someone invented the computer, metal, circuits, electricity. By itself, it does nothing. I have seen servers in racks with my own hands at the South African National Defence Force base in Tempe, Free State. 13 data centers, physical servers, physical cables, physical UPS systems and generators keeping the power on. Cooling systems keeping the temperature controlled. By themselves, just matter. But give those servers an operating system, give them software, connect them to a network, and they become something useful. Now you have a business. Let me give you a very practical example that everyone can understand. You are running a small business. You lend people money. You have five customers. Matthews owes you 500 Rand. I owes you 1200 Rand. Jeff paid you last week. You track all of this on a spreadsheet. You update it once a month when you sit down and go through your records. This works. For five customers, this is fine. Now your business grows. You have 50 customers, 100 customers, 200 customers. People are paying you on different days. People are borrowing on different days. Someone paid yesterday and they want to know their current balance today. Someone else wants to borrow more, but you need to know if they have cleared their existing debt first. You cannot update that spreadsheet fast enough. You cannot have one person update it while another person is reading it. The information is always out of date. People are making decisions based on stale data. That spreadsheet needs to become a database. And here is the key insight. And this connects to everything in cloud. Everything in technology has three versions of itself. Version 1 is the stored version, data sitting on a disk somewhere, not moving, waiting. Your spreadsheet saved on a hard drive. Your CloudTrail logs archived in S3 for 7 years. Your database backup sitting in Glacier. It exists. It is permanent. You access it when you need it, but it is not live. It is not updating in real time. Version 2 is the live version. Data being accessed and updated in real time by multiple people simultaneously. Your database recording every transaction the second it occurs. 10,000 customers checking their bank balance at the same moment. CloudWatch logs streaming as events happen. The spreadsheet has become PostgreSQL database. It is alive, it is moving, it processes thousands of operations per second. Version 3 is the cached version. Frequently needed data kept in fast memory, so you do not have to go to the database every single time. When C Power opens his banking app and his balance appears instantly, that is not because data was queried. That is because Redis already had the answer sitting in memory, ready, waiting, serving the response in under a millisecond. Same data, three completely different access patterns, three completely different technologies to serve each pattern. C3 for storage, permanent, cheap, slow to access. Aurora for live database, real time, transactional, consistent. Redis for cache, fastest possible, temporary, expensive, per gigabyte. Cloud engineering is knowing which one to use and when, and why, and what happens when you use the wrong one. Your spreadsheet became a database. Your database needs a server to run on. Your one server becomes five servers as your business grows. Your five servers need to be housed somewhere, a server room. Your server room becomes a data center. Your business expands to Cape Town, Durban, and Johannesburg. Now you have three locations, each needing their own servers. And someone has to physically travel to each location to configure those servers, to install software updates, to replace failed hard drives, to add capacity when traffic increases, to fix network issues at 2 in the morning when the system goes down. That is expensive. That is slow. That is a nightmare. An engineer in Johannesburg gets a call at midnight. Server in Cape Town is down. First available flight is 6 in the morning. By the time they arrive, 8 hours of downtime, 8 hours of customers unable to access their accounts, 8 hours of transactions failing. Engineers said there must be a better way.